Hi, welcome to exercise 2, and here we're going to be looking at the planar tracker in a lot more detail. As I said at the end of the last exercise, the planar tracker really is the fundamental basis for pretty much the entire Mocha Pro software. So once you get this down and understand how it's working, then the rest of the program should seem fairly straightforward. All right, so let's actually step away from Mocha Pro for 2 seconds, and I'm just going to discuss what a plane actually is. Well, I'm here in After Effects, but I'm not going to be doing any compositing work in After Effects in this exercise. I'm just going to be using it to draw things. So what we're talking about here is geometric planes. So basically, a geometric plane is a shape that is 2D and is infinitely thin. So it's a proper 2D shape. But we can distort this in a number of different ways. So actually, if we look at our original footage here, let's start to identify the different planes that are here in this actual piece of footage. Now, coplanar objects are objects that share the same relationship to the camera, relationship in space to the camera, I should say. So if we look at, let's just get my handy little. So if I get my handy little paintbrush going on here, we've got a number of different planes just in this one simple shot here. We'll start with the back. We have the background. That's a single plane that has a specific motion compared to the camera. So all of this background moves in a similar fashion to the camera. Making our way forward a little bit, we've got the arm here. So this has one particular movement. Let's look at what happens with this hand, because we actually can't really class the whole of this hand as coplanar in the same way, because if you look, actually the bending and twisting of this arm here means that this area here is moving in a different way to the forearm, so it's actually twisting. So we can't call these two objects coplanar. In the same way, if we take a look at the footage here, the fingers themselves are changing and moving in a different way to the rest of the hand as well. So these fingers would be on a separate plane. They'd have a separate. So these would not have a coplanar movement to the other bits of the arm. Now, what would be another plane here is this little object here, this little circle thing or half circle, because that moves consistently with the camera. And the same, let's move over here. We can see her body exists. Let's actually use that sign again. Her body exists as one shape. So the entirety of her body moves in a coplanar way to the camera. But her arm here, let's just move that there. Her arm, as that swings upwards, will also be a shape on its own. So what we're doing when we're thinking about planes in terms of Mocha Pro is actually just splitting up the image into separate areas and separate shapes that have the same relative motion compared with the camera. So let's actually move to a different one over here. And this has the same sort of thing. This is a slightly different example because we have our wall here. Now, the entirety of this wall is one plane. This whole wall here is coplanar. but obviously her hand would not be. Let's take a look at what that hand's doing. The shape of that hand stays relatively the same throughout the entire image here. If we wanted to, for example, rotoscope this, it might be a bit foolhardy to treat this hand as one shape, because this particular finger here is moving in a slightly different way to the rest of the hand. But when we come to, we'll have a look what happens when we come to track this in just a little bit. So all of this will be one plane, and finally, just for the sake of argument here, this would pretty much be in one plane as well. Actually, I'm going to revise that. The body would be in one plane, and this rear arm, the rear upper arm here, would have a would be in a plane of itself. So it's all about splitting up the image into different sections and working out what it is you're trying to track. So how does a planar tracker differ from a regular track? Well, let's take a look, and let's use my little tracker solid here. Okay, with a regular point tracker, what you're looking for as particular points of reference to track are certain areas of high contrast with definite detail. So, for example, corners that have a good amount of contrast, such as this area here, our little crosses. These are fantastic to track, because that's basically what the point tracker is doing. It's looking for a specific area and tracking that particular point. One of the downsides of that is that if there's significant changes in that particular point, so for example, the lighting changes, or there's a significant amount of motion blur going on just in this point here, it becomes very difficult to track that area there. So, or if we don't have any particularly good points of reference to track, then the point tracker kind of falls over. So here, for example, so it's quite tricky to find within this particular area a fantastic place to track. You'd have to make quite a large little shape here and hope for the best. And if you add motion blur into that mix, and let's do that. Let's just quickly animate this from one side to the other. When I say quickly, I mean over a few frames. So we'll add the motion blur. So add the motion blur into that mix, and it becomes very, very tricky to actually start to see where it would be that our point tracker would be able to hit. Now, the difference between a point tracker and a planar tracker is that Mocha doesn't track points; it tracks textures, for want of a better word. So the advantage of this is that things like motion blur, noise, changes in lighting, for example, these don't throw off the tracker in the same way as they would do a point tracker. So let's actually take a look at that in practice right in Mocha Pro. Cool, so we have our same footage loaded within here. And the problem we've got is that for a point tracker, we have very few. I want to track this this object here, and for a point tracker, we have very few decent tracking points with which to work. We might be able to get away with tracking this area here, but of course that disappears in the motion blur. And then maybe if we, tracked another little section over here and then put those two together, that will work out quite nicely. We don't have to do that with Mocha Pro. What I'm going to do now is just create a shape. So come up to my toolbar. I'm going to use an X-spline here. Generally, I'll be working with X-splines to create the shapes that I'm going to need for doing the tracking. I'll always start on the best frame, the frame which has got the most information. So this is pretty much like any other bit of motion tracking. You always want to start where it's going to be best and then work your way along from there. So whether you have to track backwards once and then, forwards once and then backwards again after that, that's all fine. So let's come in here and we'll create a layer name, and this is going to be circle track. Now I always like to add track to the end of my my layer names, just so that, as I said before, when we start working with lots and lots of different layers, it gets kind of tricky to start figuring out what everything actually is. So I'll stick track at the end of the tracks and mask at the end of the layers that I'm using for rotor splines. Cool, well let's look down here at our tracking module. So the tracking tab here, let's work our way from left to right. Just going to have that selected. So the first thing we've got is our input clip, and this is which clip we're going to be using to do the track. And this will come up with a list of the different input clips that we have. Now for the moment we've only got our master clip in here, and generally speaking that's going to be the one that we'll be tracking with. If we're working with interlaced footage, we also have the ability to track individual frames. This is really useful when you're working with interlaced footage that has a lot of fast motion in it, where things are changing quite significantly from frame to frame. This gives you the chance to be a lot more accurate with your track, though it does take twice as long to work through the track as if you had this turned off. So generally speaking, if your footage isn't moving very fast, you should keep this turned off, and then only when you're coming to problem areas could you turn the track individual fields on, and then get a slightly more accurate track going on in there. When it comes to pre-processing, we have the input channel, which is either going to be luminance, so taking a look at the brightness values in the shape that we've got selected, or we can go auto channel, and then Mocha will go in and take a look through our color channels and figure out which is the best contrast channel to look through there. In this case, luminance is going to give us the sort of best results. There's pretty much no real color difference in there that's going to help things out. Later on in the course, we will be seeing quite a large range of different footage and places where the auto channel is actually going to be the better choice. Now, the minimum percentage of pixels used is a very important setting, and one that is misunderstood a fair amount, especially with people who are just starting out with Mocha's planar tracker. So what this means, it's kind of like an accuracy that you have to have between the different frames. So as I said before, Mocha isn't tracking points, so it's tracking this entire texture that's within this shape. So what percentage of these pixels does Mocha have to find in the next frame before it then feels it's got an accurate enough track to move on to the next frame afterwards? So let's take a quick trip back into After Effects just so I can show that a little bit easier. And let's take our little box again. Okay, so we can see that our box is moving quite significantly, and it has, let's move this in so it has a significant amount of motion blur as well. So if I was tracking this in Mocha, I would select an area here. Let's come in and take that to none. Okay, so I would select this area here. So to move on to the next frame, how many of these pixels does it need to go to? This is, obviously going to get further complicated if I move this into 3D and start to rotate this around even further. And then if we start adding noise and motion blur into the mix, this is going to start to get, even more tricky to get a perfect one-to-one pixel match here. So I've got a few simple rules of thumb that I use just to get me started with what this value should actually be. Now, the larger your frame is, so here we're working at HD 1920 by 1080. So the larger your frame is and the larger your shape is within this frame, actually the fewer the percentage of pixels used actually needs to be, because you'll have a huge amount of pixels to choose from, and using a lower percentage here is still going to give you accurate results. They're just going to go a bit faster. In the same way, if you've got footage that's very noisy, having this minimum percentage of pixels turned up too high is going to give a less accurate result than having it turned down and getting a sort of average of the entire texture going on here. And we'll be looking at this concept in more detail, in more practical terms, as we sort of work our way through the course. We'll see times where that rule of thumb has to go out the window. And, this is not an absolute rule. And we'll see times where I'll have to break it to get the results that I actually need. So the next one down here is the smoothing level. This is here to sort of even out any sort of noise. It's the equivalent of sticking a bit of blur on the image before doing any of the tracking. Now, as we move to our motion over here, this is what type of movement we're going to be working on. So we've got translation. So translation is going to be tracking position, X and Y. We have scale. That is obviously going to be tracking scale as the object gets bigger or smaller, in addition to the position, X and Y. We have rotation, and that's going to be the image obviously rotating as it's also scaling and as it's translating. Just going to get rid of my my mask here because that's confusing things a little bit, and reset my transform again. We have shear, and shear is going to be what happens as we start to bend and stretch this shape in many fun different ways. Not just a slant, but basically any sort of shear movement like that. So really the equivalent of what you can do with a corner pin. And then finally we have perspective. Now this will do some extra maths as it starts to calculate things around for objects that are moving in perspective, and we'll be coming to a nice example of that very shortly. So these have a hierarchy. So if we want to track perspective, we actually have to track all of the rest of the stuff as well. We can't just track perspective. We get translation, scale, rotation, and shear thrown in for free. In the same way, if I wanted to track rotation here, I'd also get scale and translation thrown in for free. So I can't just track translation and rotation. I need to also track scale in there. So it actually doesn't cost us anything too significant in terms of time or accuracy. And we don't really want the rotation data when we take it out into our compositing app. So if we don't want the scale data when we take it out into our compositing app, then we don't have to use it. We can just pick and choose which bits we actually want. But when it comes to the tracking, we need to follow this specific hierarchy. So when it comes to this particular clip, I only need to track translation. And basically the further up you go here, the slower the track is going to be. Now, Mocha Pro is a 64-bit app, and if you're only used to working with Mocha version 1, there are some significant speed increases in there, and you'll notice those especially when you're working with high definition frame sizes and above. So the next little box here is what sort of movement are we going to be tracking? Are we going to be looking for a large motion between the frames? Is there large motion between the frames? So if there is, what happens here is that Mocha will use our search area, which we're going to come through in a little moment, to help look for those and then optimize the results afterwards. If we're just taking a little bit of sort of camera judder, we don't want large motion messing things up. Basically, what we get here with a small motion is we don't use the search area. It looks at a lot more limited area, of course, and just sort of tracks those small motions. So this is great for sort of just evening out some small sort of camera judder, because if you turn on large motion, you might be getting a bit more movement and less accurate results than you'd otherwise want. Manual track is when everything else fails and you need to add some specific manual points to the track. For the most part, you want to steer clear of this as much as possible, because a great deal of the time you're not going to be as pinpoint accurate as the automatic tracking is going to be. Okay, let's take a quick look at large motion then. So large motion turns our search area back on, and currently our horizontal and vertical search is set to auto, so this turns the decision making of how far it searches over to Mocha Pro. If this isn't giving you the accurate results that you need, you can turn auto off and then fiddle with these sizes as you need to, but generally auto is going to give you a good result for what you're going to need. Angle and zoom percentage specifies a maximum angle and zoom change that you're going to get from frame to frame. Setting these at 0 is going to be pretty much okay for much of your footage. Mocha Pro is able to model a certain amount of changes in angle and changes in zoom without you putting stuff in here. We will be looking at a particular piece of footage when we come to the insert module, where we will be playing around with these parameters a little bit more and seeing those in action. And the final one here, before we actually start to do any tracking, here is export data. And this, of course, lets us export the data that we've been tracking. So either taking out the tracking data, which we'll be doing in a second, or exporting out shape data. So for our rotor splines, if we've been using Mocha Pro to do rotoscoping. Okay, cool. So let's actually start looking at the track a little bit. And for this, I'm going to come all the way over here to my track buttons here. We have track backwards, track one frame backwards, track the current frame, track the next frame, so track one frame forwards or track forwards. And these buttons so the icons for these buttons look very similar to the icons for the general sort of playhead buttons over here, but the only difference is they've got a little T on them. Also, if you've been working with Mocha version 1, you're going to be fairly used to sort of clicking around this area to do your tracking. So it's going to take a little while for you to get used to the tracking buttons being over here. But, but it'll come. All right, let's track this backwards, in fact. So let's hit my T, and let's see what happens. Okay, so we're coming out of frame here, and this is another area where where the planar tracker is different than working with a regular point tracker. So with a regular point tracker, if your point left the screen, that'll be it. Your tracking will be over. You'd have to either find another point or manually track the rest of the footage. So luckily, because we're tracking this entire texture still, and we're only looking for 30% of the pixels moving from one frame to another, we can still track backwards without losing the accuracy of our track. And if I need to change the shape of the shape here, I can do that. And let's actually bring this all the way over here a little bit more. So long as I'm moving everything coplanar, then this should maintain the accuracy of the track well enough for us to work with it. So you can see I've got a significant amount of the shape that's now outside of the frame, and yet it still tracked that pretty nicely. Now, don't get fooled as we come through to the we can see which bits we've been tracked here. So where we've got our purple line, our blue purple line over here, these are frames that we have tracked, and the red is frames that we've not tracked. So don't be fooled by the fact that our shape is changing between these keyframes. We've still got a great track between these frames because we've already tracked them before we change the shape. And I'll be talking a little bit about keyframing these in later exercises as well. Okay, so let's come to our other frame and let's track it forwards. And you can see that even though we have significant amounts of motion blur, and moving out of frame again, whoops, moving out of frame a little bit too much there. You see the accuracy dropped off just a bit. But even though we had significant amounts of motion blur throughout this section here, we're still tracking things through fine. So let's select all of these and find another place to track. Let's make our shape nice and big. In fact, this is so big now that I can probably turn down the minimum percentage of pixels used to maybe even 20% because I've got quite a large area that I'm tracking here. Let's track that forwards. You see, because my shape is slightly bigger, it's taking slightly longer to track it. And again, the original stuff, the original part of the area that we were tracking is now completely out of frame. We're relying solely on us changing the shape there. Cool, so now we've tracked everything. How do we check the accuracy of that track? The shape data that we see here, the shape that we see kind of moving around as we keyframed it back and forth. This isn't actually the tracking data that we would be exporting out. This isn't this stuff down here. That tracking data is actually tied to another part which we come up here and we go show surface. And this is actually now called show planar surface. So this is the plane that we have now created with our track. And we can drag the corners of this to create our planar shape. And we can make this, in fact, if we wanted to make this longer, we can grab any of the sides as well, and that will move the relevant corners with us. Cool, so let's get rid of our shape data because that's, or get rid of our spline because we don't really need to see that anymore for this particular part. We're checking the track accuracy. So I'm going to come in up to this button here, just turn that off. Great, so the surface, let's see what the surface does. And let's just play that back. So what we're looking for here is the surface moving in a consistent way, or a way that's consistent with the camera move. And it's not particularly accurate from here on. So I've got significant problems with my track, and what I'm going to do is, instead of playing around and keyframing anything, I'm going to come back into my shape here. Let's find this. Come on here, I'm going to delete that other keyframe that we had back there. So I just move to the keyframe, hit the minus button there, and I'm just going to make this a lot bigger here from this area. And let's track that forwards again. And come back, turn my surface back on, turn my shape back off. Let's see how that's working now. There we go, that looks a lot better. Cool, but it's it's a little bit tricky to see when we're just working with these 4 points here. So what we can also do is we can turn on a grid, which is just next door to it, and we can use this grid to match up the shape quite nicely. Now the grid itself is controlled entirely by the 4 points of the plane, so it's just a visualization tool. We can come into our viewer preferences up in the top right hand corner and turn the grid up just a little bit there. And then play that back. Just turn the surface off here, play the grid back, and look to see if we've got any weird motion going on within our grid. And that's looking fairly good. Cool, let's turn the surface back on and the grid back off. We've got another little thing we can do to check out what we're going to do, and that's using the insert clip over in the layer properties over here. And we've got several built-in ones here. We've got a logo. We've got several different types of grid. If we really wanted to, we could come in and import a particular clip. Let's import just another clip we have here. And we can see how that would look inserted. It doesn't have to be video, it could be a still as well. In fact, and what I'm going to do here is change this to our logo, turn off my surface and just play that back just with the logo, just to see how that's looking. That's looking pretty good. So now we've got our translation track that we're happy with. We can export out that tracking data, and we've got a whole variety of different applications that we can go to, and we can take it to. We can take it to After Effects as a corner pin. So what the corner pin data would give us is what the surface would show here. So the 4 corners of our surface, that would be our After Effects corner pin. And we've got 3 different types of corner pin to take it out as. Either as a CS3 corner pin. So this is working with the CS3 pixel aspect ratios. We've got the After Effects corner pin data only. So this is basically going to just export out keyframes for the 4 points of our surface. The final one, the After Effects corner pin supports motion blur, is going to take out position, rotation, and scale keyframes in addition to the corner point keyframes here. So that's going to give us the ability to use After Effects' built-in motion blur, which taken out as just a regular corner pin data, that doesn't allow us to do that. And we've got the same sort of thing, the same corner pin thing, that we can take it out for other applications as well. So we can take it out for as a Final Cut distort, a motion corner pin, nuke corner pin, Quantel corner pin. And if we wanted to not take out the corner pin data at all, we can take out the transform data. So the transform data takes out the anchor point, scale, position, and rotation, and it takes that. Well, it takes the center point of that from the center point of our surface. So here, the center of our surface is here. If I move this into a weird and wonderful little distort, the center point of our surface. So what would actually be the anchor point for our scaling and stuff? That would be the center of this surface, whatever shape it happens to be. And we can take that out to After Effects, to the Autodesk IFFS SE, so taking it out to flame and combustion, etc. Taking it out to Avid, to Fusion, Nuke again, Final Cut again, Motion again. We've got all of these different applications we can take it out to. And if I just hit save, that's going to just let me save this data to our hard disk. Alternatively, some applications support pasting keyframes directly from the clipboard, so we can just copy this to the clipboard and then paste it directly in to our target application. Cool, that was a fairly straightforward track looking at translation. In the next exercise, we're going to be looking at taking those a little step further and looking at the different types of motion that we can track. So I will see you over there.